Today we're going to be looking at a new topic called statistics. And statistics is used not only in maths, but quite a lot in science as well. You will notice that I've put on the lesson log that there is a handout associated with today's lesson. You may want to have a look at that handout and print it out first to see which notes you may need to record or which notes you've actually got printed out. So if you've got access to a printer, please pause at this point, go and print out the handout notes, and then you'll know how much notes you need to take today. So statistics involves collecting, organizing, and representing and displaying data. Okay, so we collect different types of data, and it's the way that we can actually organize it and represent it. Okay, in statistics, a variable is something measured or observed, but can change over time or between observations. I guess if we look at sports statistics, for example, between games there'll be different number of possessions or different number of goals or points scored. So that's why we talk about it being something that changes. It's a variable. So I've got a bit of an example for us here of Marcus Bontempelli, and I've got some of his statistics here which I took from the AFL website. I mean, you can see a few things here that they've got. There's lots of stuff with regards to his height and his weight, his date of birth, number of games he's played in 2020, and so on. So there's lots of statistics that's been collected. You'll notice down here that they've actually shown statistics also in a graphical way. Okay, so we can see that we've got our round 10 through to round 14, and it talks about the number of disposals or kicks. So it's actually been shown a couple of different ways. They've even used color coding to try and help us understand different types of statistics. So this is a bit of a practical understanding for us as to how statistics is used. So classifying variables. So there's ways for us to identify different types of data or different types of variables. Now the first one is numerical. And there's a big word here which is called quantitative. Don't get too caught up with the word. When I see the word quantitative, I think about quantity. And when I think about quantity, I'm always thinking about numbers. So this is data that is numerical. In other words, it has to have a number to it. Okay, there's both types of data. One is with a number, one is without numbers. In this case, we're talking about numerical. So we have height, profits, maybe if it's a company, a number of Smarties in a packet, all those sort of things. That's something that we would actually count that would have numbers associated with it. So that's our first type of data. Now, we can also split numerical data into two different things as well. So one of them is called discrete data. Now, discrete data is numerical data, so data that contains numbers that can only take certain values. For example, if you think about shoe size, there's only a set number of shoe sizes. It'll be a size 6, a 6.5, or a 7 and a 7.5, or an 8 and 8.5. We don't have 8 3/4, and we don't have 7 1/4. So that takes certain values only. Even with goals scored, you can score 1 goal, 2 goals. You don't score 1.75 goals, or you don't score 1.3 goals. Number of mobile phones in a household, for example, that's another one that would be classified as discrete. You're only going to have a whole number. It's either going to be 2, 3, 4, 5 mobile phones. You can't have 5 3/4 or 5.75. Okay, so that's what we call discrete data. So they must have certain values only. So that's one of them. And next one is called continuous data. Now, continuous data means it can take any value. And a lot of the ones that we talk about when we're talking about continuous data, we're often using stuff that can be measured. So we've got height, which measures in centimeters or feet or meters. We've got weight in kilograms or grams, however we want to measure that, or time taken. So notice for all of these, it can be any value from the point of view that it's something that's measured. Okay, so that's something for us to keep in mind. Continuous means it can take any value. Discrete means there's only set numbers it can take. So that classifies all of our numerical or our quantitative data. Okay, data that contains numbers. We also have categorical or qualitative variable. Okay, now what does this mean? It means that it's data that's not numbers. Okay, so we can also collect data. It doesn't necessarily have to have numbers. And a couple of examples here for us would be eye color. We can collect the data from our maths class and work out who's got what eye colors. Okay, We can look at brand name of clothes. We can do a bit of a survey about AFL team that you follow. So notice, none of these actually contain numbers in them, but it is still data. So categorical data or qualitative is qualitative data. I look at it and think about something that can be split up into categories. Okay, and that's where we get categorical data. So that actually, this little map here shows us the different types of data. Now, I've actually given you this as a handout, so you don't need to copy it down if you can access a printer. If you can't access a printer, you might have to pause and copy this in because it's something you're going to refer to today, especially when we're doing our maths-based task. So now that we've looked at some of those data and we've identified it, I've actually put the little map for us on this page with Marcus Bontempelli just to have a look at the different data that we've got. So most of the data in here you can say is numerical. Okay, so it's all the data contains numbers. We've got continuous numerical data or quantitative data. For example, his height and his weight. Okay, they can be any number, and they're what we would call continuous. Okay, so they're numerical, quantitative, and they're continuous. But there's also some discrete, and we'll look at the games. For example, in 2020, he's played in 14 games, for example. And in his career, he's played 141. And again, there's certain numbers. He can't have 150 games in 2020 because there isn't that many. Okay, so we have to think a little bit about some of these things. Okay, there's only a certain number of games you can have in a year, however many games I have in a season, and however many games in a career is going to be dependent on how many years he plays as well. So these ones here are what we would call discrete. Same with goals scored. Okay, in 2020, Marcus has scored 9 goals. In his career, he's scored 124 goals. So again, these are fixed numbers. He's not going to score 1,000 goals in the year 2020. It's only going to be certain numbers that we can score, and they're going to be whole numbers as well. So we've got continuous and we've got discrete. Now, some of the data down here is actually averages, and we're going to talk about averages in some of our other lessons. And that's why it talks about 0.4 and 0.9. So don't get too confused. You can't have 10.9 kicks. But what they've done is added up all of his average for the season, divided it by how many games he's played, and then they've just given us the value. Now, we have got categorical data, okay, where they've split things up into categories. They've actually used color coding. So you can see here they've got elite, above average, average, or below average. They've used this color coding to help us. So we can look at this data and say, disposals in a season, well, Marcus Bontempelli's above average. It's green. His kicks, they're above average compared to the other players in the AFL. His marks, this yellowy colour, which is average, so he's on average compared to the other players. Total clearances, again, he's above average. He's in the green when it's compared with other players. So this colour coding here has split it up into categories for us, and we can look at the colours and just identify whether he's at average, above average, or below average. So there's a little bit of categorical data here, mostly numerical data. Now we're going to look also at different ways of collecting data, and we can call these primary data is the first one. So primary data is that data that you've collected yourself. Okay, so it's data that you've actually been involved with. Primary data usually collected by observation, by measurement, by survey, or by experiment. Normally when you do science experiments, you're doing some sort of data collection, you do an experiment, and you would record that data. Because you're actually collecting it, that would be primary data. Secondary data is data that has been collected by someone else. Okay. Sometimes we can get secondary data from books or magazines or internet sources or from the government. Now there's an Australian census that takes place, for example, where they interview everyone, sporting clubs, from the media, from newspapers. So we can look at certain data from those different types of sources. We don't collect them ourselves. We might want to know what was the most popular TV show on a Monday night. Now, we can't do that survey ourselves, but we can look it up on the internet analysis and work out that a particular show is the most popular for that evening. Okay, but we couldn't collect it ourselves. It's something that we would rely on someone else. So primary data, we've collected it. Secondary data, it's someone else has collected, but we're using it. I'm going to give you this as a handout as well, so you don't need to copy it. And probably only this section here is what you might want to copy, and just say that primary data is collected by yourself and secondary data is collected by others. I'm going to move on. So now, the way that we go about collecting this data. So we've got this word census. Some of us may have heard of a census because there's a census that takes place every 5 years where the government actually surveys every single household. Okay? Or we can look at a sample. So when data is to be collected from each member of the population, so everyone, it's known as a census. So census means everybody's involved. When data is to be collected from some members of the population, it is known as a sample. So we might want to do a survey at school, and if we surveyed the whole school, that would be called a census. If we surveyed maybe just the year 7s, that would be a sample. Or maybe we could survey just the girls, for example. That would also be a sample. And the last one here is that when we cannot choose which members of the population to survey and can record only those visible to us, this is called an observation. So we have a census, which is absolutely everyone, a sample, which is usually a sample that we've identified that we want to focus on, or we can have this idea of an observation, and we'll go through some of these examples later on. This is another handout that I've got prepared for you, so you don't need to copy this down if you've got access to a printer. If you don't have access to the printer, please pause and copy this. I'm going to move on. So statistics, classifying numerical, quantitative. So we're going to look now at the data below and work out, is this discrete or is it continuous? I've put the little map beside it to help us. So the first one here says the times of the songs on a CD. Now, for those, I guess CDs are probably a little bit old-fashioned these days, but on the back of a CD, it'll have the length of a song. It'll tell you how long it goes for, the time. Is that going to be, well, we know it's numerical because there's numbers, but is it going to be continuous or is it going to be discrete? Well, it's going to be continuous because the time of the song can be any time. Okay. The number of songs on a CD. Now, the number of songs on a CD is going to be discrete because it's either going to be 10, 5, 6, however many. It's a fixed number of songs on a CD. You can't have 6.32. You can't have 5.5 songs. It's going to be a discrete number. The number of brothers and sisters I have or you have, okay, again, that's going to be discrete because it has to be a whole number. Okay, you can't have 3.5 brothers or 3.25 sisters. It's going to be a discrete number. And how tall my brothers and sisters are, well, we need to think, is it continuous or is it discrete? When we're thinking about height, we're normally thinking about measuring, which means it's going to be continuous. They can be any height. So this is just to help us understand the difference between discrete and continuous. You don't need to copy this down. Moving on. So collecting data. This is another one for us. We talked about our census, sample, and observation. So we're going to do this exercise together. It says 25% of the student population of CRC were surveyed. Which would they prefer? Hot dogs, pizza, or fish and chips? So we've gone ahead, we've done this survey, 25% of the student population. Is it a census? Is it a sample? Or an observation? Now, if we've got our little sheet beside us, hopefully we've printed it out, or we're looking at our notes, we'd know that this is going to be a sample. And why is it a sample? Because only 25%, only a quarter of the students were surveyed. We didn't survey the whole school. If we surveyed the whole school, it would be a census. But the fact that we've surveyed 25% means it's a sample. To find the most popular breed of dog in the city of Brimbank, all registered dog information in the city of Brimbank was reviewed, counting the various breed types. So we want to work out what type of dog is the most popular in the city of Brimbank. And there's different ways that we could have done it. We could have went and knocked on the houses of 3 or 4 streets. We could have sat outside on a main road and watched people walking their dogs. But in this case here, it tells us that all registered dog information in the city of Brimbank, which means that if it was every single dog that was registered, it would be a census because all the dogs were taken into account. Okay, so every dog that lives within the city of Brimbank that's been registered, which every dog should be registered, that was taken into account. That's why we call that a census. You don't need to copy these again. This is just a couple of examples for us. So in order to determine the most popular vehicle colour in Keilor, 5 Year 7 students stood in front of CRC, noting and counting the colour of cars that drove past. So we need to think a bit about it. Was it a census for the most popular colour in Keilor? Did we look at all the cars that were registered in Keilor and identify their colours? Well, no. Was it a sample? Did we decide just to go and look at the car park in a certain spot, for example? Maybe we went to the local supermarket and looked at the colour of the cars in that supermarket. No. The fact that we actually only did it by observing would mean that this is observation. Okay. Only the vehicles that drove past CRC were taken into account. The vehicle population was not chosen, only those that drove past were observed. So we didn't actually pick anything specific. It wasn't a specific sample. We could have chosen just the cars of the students that come to school, for example. That might have been a sample. But the fact that we just did it by observation, this would be observation. So hopefully this helps you understand the difference between census, sample, and observation. That concludes our presentation for today. Please refer to the lesson log for the maths-based task that has been assigned. My word of advice is to read the questions carefully. There'll be a lot of worded questions and it might ask you to select one answer or more than one answer. So read the questions carefully. Keep your notes or the handouts close by so you can refer to them to help you. And if you get stuck, please email me and I'm happy to assist. Thanks.